When it comes to cybersecurity, the biggest threats are the ones you never see coming. SecureWorks detects and responds to cyber attackers' ever-changing tactics. We come armed with Taegis, a security analytics platform designed to recognize attacks and stop them before they do harm. SecureWorks, defending every corner of cyberspace. Learn more at securityweekly.com/SecureWorks. The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys CloudView, the next generation of cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. CloudView enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, and prove compliance in audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. Don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. All right, so our second interview today is sponsored by ExtraHop. Edward Wu joins us to talk about an MRI for the cloud, network data for cloud visibility, detection, and IR. Edward is a senior principal data scientist at ExtraHop, holds over 10 ML and cybersecurity patents, and is a contributor to the MITRE ATT&CK framework. Welcome to the show, Edward.
Thank you. Glad to be here.
Yeah, glad to have you here. Definitely a great topic. Very interesting topic. We were just talking about how it's visibility in the cloud has been much improved since the different cloud vendors have added the ability to grab flows, to peer into network data. I think there was this kind of awkward time in the cloud where to get that data, you kind of had to fool around with routing in your VPCs and stand up like an EC2 proxy or something like that and funnel all your data through an actual appliance in the cloud, which was not ideal, right?
Yeah. So in the last few years, the network as a data source has been more heavily adopted by the practitioners, which obviously prompted the big cloud service providers to improve their support for the acquisition of the network data in the cloud. Obviously, VPC flow logs and flow logs of various types is one example. But in addition to that, various cloud service providers also improved the ability to mirror full packets from different workloads as well.
So before we dive in too deep into some of the details there, help me understand what you do at ExtraHop as a senior principal data scientist. I could think of that going in a bunch of different directions, right?
Mm-hmm.
So I'm kind of interested in what your role is there and what kind of stuff that you get to play with in your job, because it sounds like it'd be really interesting stuff that you get to do.
Yeah. So I definitely have many different hats at ExtraHop. You can say my day job is leading our AI, ML, and detection products. So that involves building new machine learning models, building detection capabilities and machine learning infrastructures that enable our cloud-based machine learning service to detect, as well as help our customers to investigate potential cyber attacks in their networks. But in addition to leading our AI, ML, and detection efforts, I'm also spearheading our product expansion to cloud workload security, because obviously cloud workload is a key part of the future of IT. And we as ExtraHop do see a tremendous need and opportunity where right now the security teams are struggling to understand different aspects of the workload that's running in their cloud accounts. And we felt like our technology could help.
So just to clarify, because in my head, I might have an old school definition of cloud workload security, but generally workload to me, sounds like you're installing an agent or somehow getting telemetry from a system where you control the operating system, but maybe that also extends to containers and more abstracted, maybe even serverless stuff. So help me understand what you mean when you say cloud workload.
Yeah, so by cloud workload, we are defining any code that executes in a customer's cloud accounts to be cloud workload. And obviously that includes the traditional subset of cloud workloads that most people are familiar with, such as infrastructure as a service, as well as containers. But in addition to that, there are also other types of workloads in the cloud, such as platform as a service, as well as serverless. And ExtraHop, our focus is to utilize network data to provide comprehensive visibility as well as detection insights to all types of workloads in the cloud. Because as you mentioned, a lot of legacy cloud workload security technologies rely on the installation of agents. And obviously agents is one of the three foundational data sources for cybersecurity. However, there are many practical challenges with the deployment as well as coverage of agents in the cloud. And that's where network data could help.
Gotcha. Yeah, and so I imagine you'd be collecting. We mentioned flow logs, but in addition to that, perhaps logs from the control plane itself. So CloudWatch, stuff like that. And maybe other, I guess, more function-specific cloud data. So not necessarily from the cloud, but from systems that live. You said pretty much everything in any code that runs inside the cloud instance.
Yep.
So that's a lot of different stuff. How do you decide, like, is the goal to grab all of it and then sort things out, or is it more, you mentioned you work with customers on some of these problems. Is this something where you more add the different sources of data as you need them to solve a problem?
Yeah. So as a data scientist, my natural intention or inclination is to grab all the data first, but obviously practically that's not very easy to do for a variety of reasons. And right now our focus is starting with the data sources that we are most familiar with, as well as we are most differentiated at and can unlock differentiated customer value. And that the starting point of that is flow logs as well as full packets. And the reason being, obviously there are many types of workloads in the cloud. And from our perspective, if you look at cloud workloads, there are actually two planes of behaviors. There is what we consider as the CSP management plane. So those are the things such as like IAM roles, credentials. And then there's the traditional data plane where you can say packets fly across different devices. There are a lot of existing cloud security solutions that focus on management plane. There are a lot of tools out there that can detect public-facing or S3 buckets. There are tools that can detect IAM privilege escalation, stuff like that. But that's only part of the cloud workload security. Another part of the cloud workload security lies within the data plane, which is where kind of traditionally attackers and defenders have been fighting with each other in the on-prem data centers as well as corporate networks. Right now, attackers are utilizing a lot of cloud management plane techniques because the lack of tooling and the lack of the relative immaturity in a lot of the deployments out there. But we do anticipate that over time, as people do a better job locking up public-facing S3 buckets, as well as plugging some low-hanging fruits, such as IMDS v1 and some of the IAM credential misuses and low-hanging exploits, we do anticipate the attacker to be driven back to the traditional data plane where attackers, in order to break into a system in the cloud, they still have to rely on traditional approaches, such as obviously network remote code execution, exploits, brute forcing, as well as lateral movement and various pivoting techniques. And this, the data plane of the cloud workloads, is one that we at ExtraHop is focusing on right now.
So your coverage across these different areas, specifically infrastructure as a service, IaaS, to service as a service, SaaS, and platform as a service, PaaS, certainly there's different data sources from a logging perspective, and being able to incorporate those different elements into how you can capture and have some good visibility around those environments. What are some of the challenges that you find in monitoring these systems and providing some good detail for your customer as far as how to track potentially malicious activity, especially when infrastructure as a service, you could potentially have an agent as well as some log flow data, as well as some network data. Whereas with service as a service, you're just going to get log data, event log data.
Yeah, that's a great question. And I don't think we have a perfect answer right now, but there are definitely a few key points we have observed after working with customers to help them secure their cloud workloads, as well as ourselves. I would say the first point is security teams and development teams or application teams move at a different pace. And for a long time, even for on-premise data centers, we have observed this kind of velocity gap where the application teams will deploy certain application, and then the security teams will catch up to those new applications and start to add in or bolt on additional security controls. And actually, this phenomena or this delay is exponentially worse or larger in the cloud from our perspective, because cloud enables developers and application owners to innovate and build at a much faster pace than they were able to within the on-premise data centers. And because of that, one aspect we notice is very important for the cloud workload security teams is the ability to monitor assets and secure assets with in a very non-intrusive way, so that they don't stop or impede the velocity of the developers. And because of that, a lot of times, some of the traditional cloud workload security data sources, such as agents and logs, could be a little bit tricky to deploy because they involve some sort of consent as well as collaboration from the developers or application owners. And in comparison, network as a data source, either it's the flow log, level metadata, or full packets, neither of those two types of network data sources require explicit consent or collaboration from the application owners and the developers. And from our experience, the non-intrusiveness of the ability to provide visibility is really important for securing cloud workloads.
Oh, good. Thank you for that. Follow-up question around that, though. When you're looking at these different types of sources, so say you're looking at event log information from the SaaS component of the cloud, say Azure, because that's what I'm familiar with. So you're looking at Azure AD event logs. How do you go about correlating those, leveraging ML or AI in your system in order to correlate that sort of activity with what's occurring in the IaaS platform? So Azure, for this example, as far as ensuring that what activity is occurring is expected or appropriate, or could it be potentially malicious? Like, what are some of the triggers that you're looking at around that?
Yeah, that's a great question. So one thing I do want to preface by saying right now, at this moment, we're not really looking at Azure AD data specifically. Right now, we are primarily focused on network data sources, which, as I said, are flow logs as well as full packets. And in terms of correlation between the two type of network data sources, obviously there are a few keys or identifiers that are fairly static, right? For example, every cloud resource generally has a unique instance ID. And obviously, a single instance could have different IP addresses assigned to them over time, or even different MAC addresses. But by correlating IP addresses we observe from the network data sources with the instance metadata, such as the globally unique instance IDs, that give us a really strong indicator or identifier to correlate different behaviors. And in addition to that, I think you mentioned, obviously within Azure, there are certain services that you have, like the only way to get visibility is through log or event integration. But from our experience, for a lot of the other type of, you can say, workload or compute-based services, for at least AWS specifically, and obviously Azure and GCP have their own variants of flow log capabilities. But at least within AWS, one concrete example will be for Lambda functions, which is a type of serverless offering in AWS. You can actually get flow logs from Lambda functions. And that's also really powerful and really allows security companies like us to provide comprehensive visibility, so that when we have a Lambda function that's talking to a like elastic load balancer, that's talking to a web server running on an EC2 instance, we will have end-to-end visibility by joining the flow log behaviors we monitor on the Lambda functions, along with the full packets that we could mirror from the load balancers in the middle, as well as the servers running on the EC2 instance.
That's really fascinating. I had no idea you could get flow log data from Lambda. So that's very interesting. I learned something new today, so I appreciate that. So relating to what you were talking about with the IaaS and getting the IaaS components and getting flow logs and network information, one of the challenges that I've seen customers have certainly is different capabilities across the different IaaS, or at least the primary IaaS platforms, from AWS to Azure to GCP. Also with that are the different capabilities from a security perspective, but also just in general, what can be done with those different platforms and having different nomenclature across them. How are you with ExtraHop providing that visibility for customers, and sort of for customers that are in all three? Because certainly I've seen customers that are definitely in AWS and Azure, but also GCP. How are you helping customers provide that or provide that cohesive visibility across the multiple cloud platforms as well as the on-prem platforms, so that they see the cohesive single pane of glass, so to speak, across those, so they have a good understanding of what's happening?
Yeah, that's a super interesting question. And I would say it's a continuous challenge, right? Like with the rise of the big cloud service providers and their interest in locking in customers and differentiate, they kind of fragment the developer experience. Because nowadays, as a developer for AWS, you get to use things that are quite different from a developer's working on GCP or Azure has. And this kind of developer or fragmentation definitely make security companies as well as security teams' jobs quite difficult. For ExtraHop, we have a two-pronged approach. The first approach is relying on the fact that, hey, network packets is network packets, regardless if they are flying through AWS data centers or flying through Azure data centers. TCP is still TCP, HTTP is still HTTP, and DNS is still DNS. And thanks to this, essentially network data being the common denominator across all three or all large cloud service providers, as well as on-premise data centers, that give us a really solid foundation to build our analytics, because we are relying mostly on network data, which is, you could argue to some extent, very similar, if not exactly the same, across all environments. But on top of that, we do have to make a number of per CSP product changes. For example, the type of metadata you can ingest from different CSPs is different. In addition to that, different CSPs have specific background traffic, for example, that the tool or the product will need to be better at understanding, and different CSPs obviously have subtle differences that either introduces new detection opportunities or introduce, you can say, potential new attack vectors or attack techniques that as a security product we need to pay more attention to.
Great. Thank you very much for the answer.
All right. So talking about some of the use cases here, I think we mentioned IR. We mentioned a few different things there. Maybe we can dive into some of what customers are doing with the products. Where they're finding value in it, and what most of all, like what do you see in this product that really turns the light bulb on for customers and makes them realize kind of the value out of it, that they weren't getting anywhere else?
Yeah. So from our experience, there are multiple value propositions of our product. The most foundational one is probably the pure visibility of seeing something that previously they had no visibility into. And one concrete example would be kind of similar in kind of, you can say, physical security. When you turn on a light in the room, you start to see different pieces of furniture or items on the floor in a room. Enabling turning on the visibility for cloud workloads oftentimes has a similar effect. And one concrete example will be when we first were testing our product, we actually turned it on in our own data center. And we also actually noticed something that's quite interesting, where we had a database service, and we actually noticed a specific Lambda function that's querying this database service very periodically. And for a while, everybody was scratching their head a little bit and wondering, like, why is that Lambda service hitting, or is that Lambda function hitting the database service? But after a while, after tracking down the owner and looking at the code a little bit, we figured out, okay, it's a periodic database cleanup job that our data engineers have built. But as a security team, when you get this kind of visibility where you can see what's actually happening to the workloads, that provides a lot of opportunities for both knowledge, because obviously you cannot secure something you don't know what it is supposed to do, as well as other areas such as basic asset inventory, dependency mapping, as well as posture management.
Yeah, there's an allegory a friend of mine loves to use where, he says you walk up on, you're walking down the sidewalk and you come upon somebody searching for something on the ground, and they're searching under a streetlight, and you say, did you lose something? And they say, yeah, I lost my keys. You say, did you lose your keys here? And they say, no, I lost them over there, but I can see what I'm doing here. So I'm searching over here.
Yep.
And I think that's a good allegory for what you're talking about here, where people will use the tools they have, and oftentimes it's easy to forget that, there's stuff in the dark, in those other places. Like, I think Lambda's a great example there, because it wouldn't even occur to me that you could get flow logs from Lambda. I wouldn't even look for it. I would have just naturally left those out.
Yeah. Having flow logs enabled, or having Lambda functions generating flow logs is definitely a big plus to, from my perspective, to the entire security community, because Lambda functions are a little bit obviously more difficult to secure. Like, you cannot install agents on Lambda functions, and Lambda functions, because they are so lightweight, you can say a lot of times they are not very high up on the asset inventory list versus like EC2 instances or databases. Right. But Lambda function can execute a lot of code. There have been attack tools out there that actually allow attackers to create backdoors using Lambda functions. And those of the techniques obviously that definitely makes security teams' life quite difficult. But yeah, having network visibility to serverless workloads is super powerful, and it also makes sense, right? Because to some extent, at the end of the day, the purpose of a workload is to create some value or execute some automation. And because everything is so interconnected, it makes sense for the workloads to continue to obviously communicate through the network with other workloads. And even when one cannot install agents on those workloads, as I mentioned earlier, network data continue to be like a very large, or you can argue to some extent, the biggest common denominator across all type of workloads.
Yeah, I imagine one of the, some of the big value of a product like this, and it kind of goes along with how I used to train incident handlers, is that if you don't have a good baseline for what's going on in your network, there's a lot of, and even talking about kind of how people use Lambda, there's a lot of weird stuff going on that might look malicious, but it's just your company does something in a weird way, or a non-standard way. Even in commercial software, I often see, companies doing things a certain way because it works, but it looks really sketchy. It looks like something only an attacker would do. So I imagine, is that one of the use cases? Do your customers spend a lot of time just going through? And is that an option where they can kind of use the product to understand their environment better, and to get kind of a baseline on, say, for example, I'm investigating an EC2 instance. Like I need to know what it normally talks to, right? Like I need to understand what that baseline is. Like, is the thing I'm seeing normal for this box, or is this an anomaly?
Yeah, definitely. So there are a few different ways to use a product and leverage our visibility. Obviously, the easiest way to get started is probably to just manually use a product, and because we have really great visualization on different behaviors of different assets or workloads within the account. So one could definitely pivot to that. One could actually also plot an activity map or a application dependency map, showcasing, okay, for a given EC2 instance, like who else is this EC2 instance talking to? And sometimes, to be frank, looking at the dependency or activity map of an EC2 instance provides more operational context than looking at the labels that developers or tags that developers have added. Because a lot of times developers don't do the best job in the world describing or even naming the different workloads or EC2 instances, but the behaviors don't lie. So by looking at the behavior of specific workloads, the security teams can quickly identify the intended use of that workload and make, you can say, intelligent decisions on whether the observed behavior on the network of a given workload matches the intended use of that workload. So that's one aspect. Another way to use our product, obviously, as a data scientist, we didn't let go of the opportunity to build machine learning models in this case as well. So our product actually has many built-in machine learning models that also kind of performs this kind of analytics for our customers. So one example would be, let's say there is an Elastic load balancer, and then there are a bunch of web servers behind the single Elastic load balancer. And if we start to see maybe one of the web server starting to communicate outbound, for example, establishing an outbound LDAP connection, our machine learning model will actually catch that automatically as well.
Subtle log4shell reference there.
Yeah. So we also have machine learning models as well to perform this type of analysis.
Yeah. So sorry, interrupted there. You're right at the end, but I noticed that was probably a log4j, log4shell reference. Do you have any anecdotes or examples, of this? Obviously anonymous, or I don't know if you have any that have been cleared to talk about publicly, but any examples of stuff that customers have used the product to intercept or find, like maybe in a attack in progress or something like that you can share?
Yeah, that's a good question. unfortunately, I'm not at liberty to share any of those war stories right now. But I will share one thing, which is actually pretty interesting because when we were testing our product capabilities, obviously we deploy a lot of these. We deploy like the beta version or alpha version of our product internally, and we definitely during the process we didn't obviously detect any attacks or real attacks within our own data centers, but we definitely detected or saw a few, you can say, kind of unexpected behaviors, in the sense that, like I said, because developers and application owners move so quickly, a lot of times somebody just toss up a random EC2 instance and have it do something and then forget about it. So over time, like the team start to forget, okay, we actually had that EC2 instance over there doing something super important. And when we actually deploy our product internally and use it, we kind of, our application teams and security teams actually use our product to identify, you can say, a few previously unknown or maybe forgotten quirks about our own workloads, which I think is pretty cool because, like I said, a lot of times it is very important to understand the workloads when you try to secure them, because ultimately, you can say obviously different people have different definition of secure, but one could argue one definition of secure will be the workloads behaving with malicious intent, new behaviors that are not expected for the original use of that workload. And in order to detect some of these, the security teams as well as application teams really need to have a good understanding of what are all the workloads in the environment, what exactly are they doing, and what each workload, what behaviors each workload are expected to be observed. And our product provides a great validation and sometimes offer opportunities of discovery as well to identify, you can say, unknown artifacts or previously unknown behaviors, but that are actually benign, but somebody forgot about. And to some extent, we saw a lot of these cases for our on-premise customers as well. When they turn on our product, a lot of times they discover, oh, I didn't know I have a database over there that 5 of my most important application servers are still talking to. We were actually about to turn off that rack because we saw nobody is talking to it and stuff like that. So this kind of general workload visibility it is tremendously valuable.
Yeah, I think if you told somebody 40 years ago that computers would be so cheap and easy to deploy that you forget about them, like they're socks, like yep. I need more sock. I'm missing sock pairs here.
Exactly.
It's funny, but yeah, it happens all the time. Maybe you do proof of concept. Maybe the PR team, stands up, temporary infrastructure or WordPress for a 6-month campaign and forget to shut it down at the end of the campaign. It's almost like when we deploy resources in the cloud, we should deploy them with expiration dates, right?
Yeah, exactly. I think the SOC analogy is fantastic because that's exactly what happens to a lot of accounts or cloud accounts. Obviously, most large customers have multiple cloud accounts. Some of them are for production service. Some of them are for more ephemeral and ad hoc stuff. But over time, we definitely see this proliferation of people creating, you can say, one-time or ad hoc or ephemeral workloads, and then forgot about them. And also, the sad reality is most people don't spend enough time thinking about like security policies and access controls for a lot of these ad hoc workloads. So when you leave them out there for expanded period of time, and those workloads are just floating kind of in the kind of the void between the different spotlights, they do cause additional security risks. And one like very common mistake is obviously when somebody spins something up, it's very easy if that asset they just spun up is accessible from public internet and has ability to reach out to any destination on the public internet, right? It's a human, you can say, nature that we want to make things easy for ourselves, but it's that kind of security policy where it's accepting traffic from public internet and has no egress restrictions at all is very dangerous and imposes a lot of risk, not only to that specific asset, but also to any other asset that asset is reachable to.
Yeah, I know really smart security people who've said, yeah, I know this isn't the proper way to do it, but I'm going to turn it off at the end of the week anyway, and it doesn't get turned off.
Yep.
Yeah, we're good at fooling ourselves that way. But no, I think that's a good topic or a good point to kind of wrap things up on. Is just the again, it comes back to that visibility, that situational awareness of what's actually running in your environment. And having good knowledge of that, and maybe putting some expiration dates on things. I really want to see that as an AWS feature. I'm sure you could do it as a tag, maybe. Put an expiration date on something. Yeah, I think that
but
that'd
it's
be a
tricky
cool
because
feature.
people will keep renewing it, right?
Yeah,
every 6 months
right.
you get an email like, "Do you really want this?" And you're like, "Hey, I already forgot what that asset is, so I'm going to reply, yes, I really want this." I personally know I'm liable to some of those behaviors as well.
Yeah, because they'll get 40 of them at once because they'll set them all up at once, and they won't have time to look through each one of the 40. So they'll just continue.
Yes,
you're right.
Yes.
Oh well. Edward, thank you so much for joining us on Enterprise Security Weekly today. This was a really fun conversation.
Thank you. My pleasure.
All right. Make sure you visit securityweekly.com/ExtraHop to learn more about spending more quality time with your cloud workloads and understanding them better. We'll be right back in a few moments with the weekly enterprise news.